we're going to look at section 11.1, which deals with parabolas. And you hear that and you say, well, we've been doing parabolas since intro algebra, right? True, you have, but you haven't looked at them the same way that we're going to look at them here. Okay, here we're going to actually look at them not as functions or well, that's really all you've looked at them in the past, right? Not as functions, but as conic sections. All right. So if you look at a parabola as a conic section, you think of it as a curve that's formed when a plane is passed through a cone at an angle parallel to the edge of the cone. All right. And you can see the video on this at that YouTube address there, which I have in the Canvas shell. So you can look at it in the Canvas shell. Right. There's a longer one, and then there's what I call the short version. All right. So you form a parabola by passing a plane through a cone at an angle parallel to one of the edges of the cone. All right. And then geometrically, and this is really where the equations come from. But geometrically, a parabola is just the set of all points that are going to be equidistant, so the same distance from a fixed point, one fixed point that's going to be called the focus, and then a line. And the line is going to be called the directrix. Okay, so there's a little bit of terminology here that you haven't seen before. Focus and directrix, right? So the parabola is all points that are the same distance, right, equidistant from a fixed point, which is the focus, and a line, which is called the directrix. Okay, and we're going to have two different forms, right? Two different forms of equations for parabolas. X squared equals 4py, or y squared equals 4px. Okay, and just so you know, we're only dealing with parabolas that have their vertices, right, at the origin. So the turning point, if you will, right? Remember, I mean, it's the same thing that you called that turning point when you dealt with parabolas as functions. You were calling the turning point the vertex. So we're only dealing with parabolas that have their vertices at the origin. Right? 11.4, which is called shifted conics, that's the section where they get into ones that have vertices at other points besides the origin. Okay, so we'll look at the two different forms here. All right, the first form, of course, is the x squared equals 4py, and parabolas that have this kind of equation are either going to open up or they're going to open down, right? So they're going to open up if 4p is greater than 0, and they're going to open down if 4p is less than 0. So you might have a parabola that would look like this, right? This opens up. So what you're going to have is this vertex here is going to be your point 0, 0, right? Which again is called your vertex. And then you're going to have a point over here, which is going to be called the focus, right? A lot of times they'll use a capital F for that, for the focus. And in this case, the focus is going to be the point 0, comma, P, all right? And if you recall what we said about the geometric definition of a parabola, it's a set of all points that are equidistant from a fixed point, which is the focus, and a line. So if this is the point 0p, that means that to get from the vertex to 0p, I actually went up p units, and it has to be, this point has to be the same distance from the focus as it is from the directrix. So to get the directrix, I would just go now down another p units, and I would end up here. And this this horizontal line here is going to be your directrix, right? And the directrix, then you can see, since this distance here, as we said, is also p, this is now a horizontal line that is p units below the origin. So the equation of this is going to be y equals negative p, right? So this would be a parabola that opens up. The one that opens down, this picture would just be reversed, right? And the directrix would be above the curve, and the focus would, of course, be, again, inside the curve, right? So you just have kind of this whole thing flipped over, and that would basically be the situation if it opened down. Okay, so that's the one form. x squared equals 4py. And then, of course, the other form then would be y squared equals 4px. And these are going to either open right or left. So they're going to open right if 4p is greater than 0. They're going to open left if 4p is less than 0. So since here we did the one that opened up, over here I'll do the one that opens left. So let's say you had a parabola that looks like this. Right? Again, this is the vertex, so this is the point 0, 0. All right? And of course, over here, inside the curve, you would have this focus, and the focus is actually going to be the point P0 again, right? And then again, since this distance here was P units, I go another P units to the right, and I would arrive here at this line, and now it's a vertical line. That's going to be the directrix, and in this case, the directrix would be the line x equals negative p, right? And this is where you can get a little bit confused, because you might say, well, Lopez, how can the equation of this line be x equals negative p if it's to the right of 0, 0, right? You would think it would be x equals p. But you have to think that p could be a positive or negative number. And in this case over here, in the one on the right, since it opens to the left, p over here is actually less than 0. So when you do x equals negative p, you actually get x equals a positive number, right? So in the case on the right, p was less than 0. And then in the case on the left, p was actually greater than 0, right? Because I went up to get to the focus. All right. So those are your basic pictures for the parabola, the one that opens up and the one that opens left. Now there's one other thing that I noted in the definitions here, focal diameter. Focal diameter is the length of the segment that connects 2 points on the parabola and passes straight through the focus. So in the case on the left, that green segment there, the length of that is called the focal diameter. And then over here, this green segment would be called the focal diameter. And it's pretty easy to see the length of this, because remember how we talked about it has to be equidistant, all the points on here have to be equidistant from the focus and the directrix. To get from this point here, right, down to the directrix, how far is it? It's p units to get to here, and then another p units to get to here. So it's actually going to be 2p. Well, technically the absolute value of 2p, because p could be negative. In this case, it's positive, so it would be just 2p, but it's technically the absolute value. So since this distance is 2p from the point to the directrix, the distance from the point to the focus has also got to be 2p. And then you have the same thing on both sides. So if this is 2p and this is 2p, of course, you get a length of 4p, right? And then the similar thing works in the case on the right. The distance from here to the directrix, right? It was p to get to here, another p to get to here. So it was, again, absolute value of 2p. And that's the same as this distance here. And if you put that together with that one, you get 4p. So you can see how the focal diameter is going to be the absolute value of 4p. So that's just something that you pretty much can remember. And a lot of this is really that. A lot of this is just memorizing the form and memorizing how you get the focus and how you get the directrix and what's the focal diameter, stuff like that. Which is really the reason why I'm not a big fan of this section, to be honest with you. And all the conic sections, I'm not really a big fan of any of these sections because it's just a lot of memorization stuff, which I don't really care for. But some people like it, and I think they find it easier if they just have to memorize things. So that's the basic setup for the parabolas. And one just other note, that segment there that has a length of absolute value of 4p, it has a special name. It's known as the lattice rectum. That green segment there that has a length of 4p, it's called the lattice rectum. So if you see that phrase, it probably won't come up. Like I would never use that on my test, that phrase, but you might see it in some of the homework problems. So if you do, it just is referring to that segment there that has a length of absolute value of 4p. Okay? So we looked at the general form of the parabolas. Now we'll look at more specific parabolas, right? So I have two parabolas here. The first one is x squared equals 12y. Okay, so the first thing you'd really want to do with this is try to write it in that standard form that we had, the x squared equals 4py form. So we want to turn this into x squared equals 4py. So what do you see? You can see that 12 is playing the role of 4p, right? So we know from that 4p is going to be 12, which means that p is going to be 3. So what this is going to do is this is now going to help us get our focus and our directrix, right? We know that this thing has a vertex at 0, 0. And now to get the focus, what would I do? I would go up 3 units, and that would be my focus. So in this case, I'm at 0, 0 with my vertex, and since p is 3, I go 1, 2, 3 up, and I get here. So this is my focus in this case, which is the point 0, 3, right? It's always 0 comma p, and in this case p is 3. So 0, 3 would be my focus, and now my directrix is going to be just the line y equals negative p. So in this case, my directrix is the line y equals negative 3, right? And then the other thing that you can get is when I have you graph these, I usually ask you to graph 3 points. So the vertex is obviously one of them, right? It's always going to be 0, 0. That's the easy one. And then what you do is the other 2 points are easy to get because you can just use the lattice rectum, right? You can get the endpoints of the lattice rectum, So what you would do is you go up to the focus and realize that to get my endpoints of this lattice rectum, I would go 2p to the right and 2p to the left. So if p is 3, 2p is going to be 6. So I would go 1, 2, 3, 4, 5, 6, and I would get here. So I'm at the point 6, comma 3, and then I would also do the same thing going to the left. 1, 2, 3, 4, 5, 6. I get another point here, which is negative 6, 3. So there's my 3 points, right? I would have negative 6, 3, 6, 3, and 0, 0. And then I could just connect, them with a smooth curve, right? So that's what you would do with that one. All right. And the other one is similar, except now it's going to open left, right. So you would again realize, hey, y squared equals negative 8x. I need to get this in the form y squared equals 4px. So I know in this case that 4p is negative 8. So p is going to be negative 2. And again, remember, what does this do? Finding p gives me my focus and my directrix, basically, right? So my focus now is going to be at the point negative 2, comma 0. So in this case, here's my focus, negative 2, 0, right? I moved 2 to the left because p was negative 2. And then my directrix now, remember, is always the line x equals negative p. But if p is negative 2, negative p becomes positive 2. So there's my directrix, the line x equals 2. right? And I mean, it's easy to get that even if without memorization. Just realize, all right, I moved 2 to the left to get my focus. So then to get my directrix, I moved 2 to the right, and then just draw a vertical line through that point. Okay? And then similarly, as to the last one, I can use my latus rectum to get the 2 extra points, right? So I knew that p was -2, so the absolute value of 2p, right, is going to be 4, which means that to get to my endpoints of the of the latus rectum, I would just go 1, 2, 3, 4 up, and I get to the point -2, 4, and I go 1, 2, 3, 4 down, and I get to the point -2, -4. So again, these would be the 3 points that I would have wanted to graph, right? -2, 4, the vertex 0, 0, and then -2, -4, and then just connect with a smooth curve, right? And the one thing that you should realize here, and I think I mentioned this in class, the focus and the directrix are not part of the graph, but when I give you problems with graphing the parabolas, I have you draw them in, right? Now, when you're graphing them on in WebAssign, you don't plot the focus and the directrix. You just graph the parabola. But for my test and quiz questions, I actually have you graph the focus and the directrix. Okay, so we'll do a couple more problems in a sec. So I mean, you're really not going to get much different kinds of problems with this outside of being asked to find the equation of a parabola that meets certain conditions, right? So it's really going to be similar to those rational functions that we did. You'll either have a problem where you're given the equation and then you have to graph the parabola, or a problem where you're either given info about it or the graph itself and then have to write the equation. So that's what these two are, right? Where I'm going to be asked to now write the equation of a parabola. So in this case, on the left here, I'm asked to find the equation of the parabola that has its vertex at the origin. So all these are going to have their vertex at the origin. All right, so that's not going to be a question. And directrix y equals 6. So the only thing we're given here is the directrix is y equals 6, but that's plenty of info. That's all we need, right? That's all we need to get the equation. So immediately you know that since the directrix is horizontal, what form is this going to have, right? Which one had the form, which form fit the directrix of a horizontal line? It would have been the x squared equals 4py, right? Because if the directrix is horizontal, that means it's going to open up and down, up or down. So it would have the form x squared equals 4py. And in this case, remember, y equals 6. So 6 is -p, right? Because the directrix is always going to be y equals -p or x equals -p. So this means that -p equals 6, which tells us that p equals -6. And now we're basically done. That's all we need, right? I mean, just multiply 4 by -6, finished, right? Because if I know p is -6, and the form would be x squared equals 4py, so it's 4 times -6y, which is just going to be -24y. So there's my equation. X squared equals -24y. So it's pretty straightforward, right? And if the directrix was at y equals -6, then the equation would have been x squared equals +24y, right? I mean, I suppose they could have asked you to graph this also, but it would have still been very simple. I mean, how would you graph this? You would just say, all right, well, I know directrix is y equals 6. This is going to open down because the directrix in this case is going to be above the curve. So the curve is going to look like this. Here's your 0, 0. And you know the focus is going to be, since the directrix was 6 above 0, 0, the focus is going to be 6 below. So the focus is down here at 0, -6. And then remember what I do to get these other 2 points? I would go 2p, well, the absolute value of 2p to the right and 2p to the left. So if p is -6, the absolute value of 2p is going to be the absolute value of 2 times negative 6, which is negative 12, which becomes 12. So actually, in this case, I was going 12 to the right and 12 to the left. So this, I mean, this doesn't look accurate, but I mean, it all really depends on the scale that you use. So that right-hand point is actually 12 to the right of 0, negative 6. So it's actually going to be 12, negative 6. And then that one over here is going to be 12 to the left of 0, negative 6, which is negative 12, negative 6. All right, so there's your two additional points, negative 12, negative 6, and positive 12, negative 6. Okay, so that was the one type. And then the other type is just, all right, well, I have a parabola, and they give me the point 4, negative 2. Now, what you can't assume here is that that is an endpoint in the lattice rectum. It's not necessarily an endpoint of that lattice rectum. So don't assume here the focus is at the point 4, 0. It's not necessarily. So all I can really do with this is realize, all right, well, this opens to the right, so it's going to have the form y squared equals 4px. And now it's very simple. Now I can just plug in that point 4, negative 2 for x and y and solve for p. So I would plug in 4 for x, negative 2 for y. So I'd write negative 2 squared equals 4p times 4. So this is going to be 4 equals 16p. Divide by 16. So p is 4/16, which is really 1/4. Which then means, of course, that 4p is going to be 1. Right? Just multiply by 4. So 4p is 1. So then this equation is just going to be y squared equals x, right? 1x. I mean, you don't have to write the 1, but just for effect, I'll write it in there. So that would just be y squared equals 1x, or just y squared equals x. Which makes sense from this point, right? Because what happens? If you square x, right, you get 4. So 4, negative 2 would fit on that line there.